Hello, this is a video on how you can solve the 3-point problem. So we'll go through this question. So you have 3 points, A, B, and C. We also have the third point, which is D. So you're told that the depth, and this is not the elevation of the top of this sandstone in each well, is as follows. So you're told that A, we have 5,115 feet. B, we have 6,135 feet. Then you're told that C, we have 5,485. So the instructions are that you show all of your map and all your calculations. So you're supposed to determine the altitude of the sandstone bed. So you agreed it is the strike and the deep. For B, so you're told if we were to drill the well at point D, at what depth would it hit the top of the sandstone? So let us first view the points. So these are the points. You have point A, point B, point C, and this is where they're supposed to drill the well. So let us label them. So for A, so let us join the highest and the lowest point, which is point A and point B. So you'll take your pencil or pen, join the two using a ruler. Then we want to know where C is going to cut the line AB. So in order for us to do that, so we're supposed to find what is the difference between point A and point B. So between point A and point B, we have it as 1,020 feet. Then step 2, go ahead and measure the distance between point A and point B. So we have a difference in height. This is the difference in height, which is 1,020. Go ahead and measure your distance between point A and point B. Maybe you'll have it as 10 centimeters or 8. Let us say it is 8 centimeters. Then what is the difference between point B and point C? So we have it as, so that is from point A and point C, which is 650 meters. So from point A to point B, we agree that it is 1,020. So you'll see that our 1,020 is equivalent to the 8 centimeters. So you're going to say that our 1,020 feet is equivalent to 8 centimeters. So what about 650 feet? It will be equivalent to how many centimeters? So you go ahead and do your calculation. So from AB, I just guessed, you have to measure it to know what is the distance. Using your ruler, you're supposed to measure between point A and point B so that you know what is the distance. So we'll have it as 650. So you'll have it as 650, you multiply by 8, then you divide by 10, by 1,020, I have it as 5.1. So it means that I'll take my ruler and then start measuring from point B to a certain point on this line, 5.1 centimeters. That is where our C is going to cut this line. So assuming that now you're going to take your ruler, measure from point B to a certain point on that line. So that is where we'll have our 5.1 centimeters, meaning C will cut this line at this red dot here. So go ahead and extend your line. Now we know that a strike joins 2 points of equal heights or elevation. So if this is our C, we'll have our C prime at this particular point. So this is our C and this is our C prime. Then now from point B, let us drop a perpendicular. So let us drop a line that meets this line C prime and makes an angle of 90. Now we know that this angle is the angle, this is the deep angle. So let us have this as the deep angle. Now, in order for us to calculate what is the deep angle, we know that the deep angle is equivalent to the rise divided by the run. So let us have a triangle at this point. This horizontal distance is the difference in height between this strike line and point B. So we'll have it as 6,135. So let me right? So that you don't get confused. And this point, which is our C, we'll have it as the tan inverse. We'll have it as the tan inverse. You know that tan is equivalent to the opposite divided by the, which is equivalent to 650. Then you have to divide that by measuring the distance using a ruler, the distance between B and Y. Maybe you have it as 5 centimeters. So using our scale, maybe using our scale from this particular point to this particular point, maybe it is 3 centimeters. So you have it as 3 centimeters, or let's say 4 centimeters is equivalent to 1,000 feet. So then you ask yourself, what about 5 centimeters? Then you have your feet here, maybe to, let's say it is 1,350. So you find the tan inverse of that, so our deep angle. So I have my answer as 35.71 degrees. So that is our deep angle now. Okay, now you want to know about the strike. So come and draw your, have your north, you already have it. Then measure the angle, measure this angle. So whatever you're going to get, maybe a 95. So you have it as north, using the right hand rule, you have it as north, 95 degrees to the east. So that is the first part of that question. Now for the second part, you're told that if a well is drilled at point D, at what depth will it hit the top of the sandstone? So you can, if you know the distance between D and this straight line, so maybe from this to this, it's 3 centimeters, meaning if I was to measure again from the strike line, another 3 centimeters, so you have a D prime at this particular point. So let us join that line to make a strike line. So we have our strike line there. We have our strike line there. Let us extend this line such that it meets this line at 90 degrees. It means that the angle that it makes, it's a dip as well, right? So we have this line, cut this straight line at 90 degrees, you have this as our dip angle. So we can go ahead and measure the distance between this strike line and this strike line. So we'll have the distance from this point to this point. So measure it, maybe you'll have it as the 3 maybe centimeters. From this particular point to this particular point, you'll have it as 3 centimeters. Then we already know what is our dip angle, or we already know what is our rise divided by our run. So we have something like this. We have our 3 centimeters here. Then you have this angle. So you have it as 25.7 degrees here. So we want to know what will be our rise now from our point A to our point D on this. Remember the distance from this point to this point, and the same distance perpendicular, cutting it at 90 degrees from this point to this point is similar. So we'll have it as tan 25.7 is equivalent to our opposite divided by our adjacent, or you can have it as tan, our angle is equivalent to our rise divided by our run, and our run now is 3 centimeters if you were to measure it. Remember, I'm giving you just a guideline, so you are supposed to do it to scale. So you have from this point to this point as 3 this point to this point as 3 centimeters. You have this point to this point as 3 centimeters. Let's do the calculation. It's 1.44 centimeters. So 1.44 centimeters, you have to give it in terms of feet. So earlier we said that 4 centimeters is equivalent to 1,000 feet. So you ask yourself, what about 1.44 centimeter? So you'll have it as 1.44 centimeters. You multiply by 1,000. So based on our scale, you would say that your 4 centimeters is equivalent to 1,000 feet. So you ask yourself, what about our 4.44 centimeters is equivalent to how many feet? So I have minus 222. We have it as 288 feet. So we'll have this distance as 288 feet. Then from what you can see, if we had another straight line here, you have to be keen that the distance from this to the next, okay, make sure that these straight lines are parallel, so the difference between them is the same throughout. So if we had something like this, we have this as 6,135 feet. Then you have the next straight line as 5,485 feet. Then we now have the next strike line as 5,115 feet. So I expect that at D it would also decrease. So there has been some bit of changes, but stay with me. We'll still continue with the concept. So we found that the distance from this strike line D, let us call it D, and the other strike line, let us call it A, is 288 feet, right? Now that is called the run. Now we want to calculate the rise. And you remember we said that the turn of our dip is equivalent to the rise divided by the run. We already know our dip is 25.7 is equivalent to the rise divided by the run. We already know that our run from this straight line to the other straight line is 288 feet. So we'll make rise the subject, which is 288 turn 25.7. So you'll have your rise as 138.6 feet. We already know now what is the rise from between the two straight lines. We'll go ahead and subtract it from our A, this straight line, which is 5,115 feet. So it will be 5,115 feet. You subtract your 138.6 feet, then you'll have your D as 4,976.4 feet. Well, this was just but a guideline. Make sure you draw everything to scale, then you'll definitely get the correct answer. I hope this video helps you out.